In discussing the general shape of these graphs, y equals a sine of bx plus d, and y equals a cosine bx plus d. Okay, we're going to kind of keep it a little bit simple here. Remember that the sine graph looks almost like an S, kind of, whereas the cosine graph looked almost like a U. So this is a difference between the shapes of these graphs. In the case that we had to graph y is equal to negative sine of theta, what's going to happen is that now it's going to go in the opposite direction. So it would go down and then it would go up. Okay, it's kind of like the reflection. Same thing for cosine. It's going to start down, then it's going to go up, and it's going to go down. So that is what y is equal to negative cosine theta is going to look like. If you take a look at your screen, you're going to see the graph of y equals sine of theta, or y equals sine of x. Now, what we're going to do is talk about this equation right here, which is the general equation for a sine or cosine graph. Notice that it says A. The A stands for amplitude. And the amplitude is basically just equal to half of the wave height. The way you find amplitude is to take half of the maximum value minus the minimum value, and that's going to give you the amplitude. Notice that D in the equation right here is basically your vertical shift. It controls the vertical position of the graph. This is what we call the midline or the principal axis. And this is the place where the graph is constantly going back to. Notice that it's going to be the one that cuts the graph in half. And so from this midline or principal axis, to go from the line to the top of the graph, I know that this is going to be the amplitude. So in the problem that you see drawn, the amplitude is going to equal 1. That's basically the same as saying that it's half of the wave height if I were to look at the highest value, which is 1, and the lowest value, which is -1. From -1 to +1, that distance is going to be 2, and half of that is going to equal 1. So whether you think of it as half the maximum minus the min, or you think about it from the principal axis or midline to either the max or the min, you're going to get the same answer. So we talked about A as being the amplitude. We talked about D as being the principal axis, basically that vertical shift. And now what we have left to talk about is this B right here. B controls the wavelength of the graph. This is called the period of the function. And by period, we're talking about the distance it takes for the graph to repeat itself. On your screen right now, notice here's my sine graph. It starts at 0. I go up, I go back, I go down and back. That is going to be one full wavelength. So it's 360 degrees. So the period right now is 360 degrees. To figure out the value of B, the period is 360 degrees divided by the absolute value of B. So that's how you can determine the value of B. Or if they give you B, then you can figure out the period by going ahead and doing 360 divided by B. So in the graph that you have in front of you, what you have graphed are 2 periods. So here we have 2 full cycles of this sine graph. Okay, so take a look at your screen. Our job right now is going to be to graph y equals the sine of x plus 2. So I'm going to start by putting this on a coordinate plane. And I'm going to go ahead and divide this into 90, 180, 270, 360. And the reason I'm doing that is because one full revolution around the circle is 360 degrees. So therefore, I'm going to be splitting it into 4, the same way that I did at the beginning when I drew this as a circle. And then I'm going to go backwards, -90, -180, -270, and -360. Do I have to do the negative parts? No. Normally, they're going to give you a domain. They're going to tell you how much they want you to graph. But for now, I just want you to see 2 of these periods drawn. By creating a table of values, it's going to make our life a little bit easier. So I'm going to go ahead and write theta. Then I'm going to write the sine of theta. And then I had to take the sine of theta, and we're going to have to add 2 to it. So we have 0, 90, 180, 270, and 360. If you remember, y is going to be the y coordinate. So at 0, the y coordinate was 0. At 90, 1, 0, -1, 0. And now we have to add 2 to this. So 0 plus 2 is 2, 1 plus 2 is 3, 0 plus 2 is 2, -1 plus 2 is 1, 0 plus 2 is 2. Okay, so I'm going to go ahead right now and I'm going to graph this. So at 0, I'm at 2. I'm going to go ahead and put 2 and 3, -1. So we have 1, 2, and 3. So I'm going to go 0, 2. So at 0, I'm at 2. At 90, I'm at 3. At 180, I'm at 2. At 270, I'm at 1. And at 360, I'm at 2. So notice what is happening to the graph. We're going up, back, down, and back. Okay, just as expected. If I go backwards, I'm going to continue this pattern. So at -90, I'm down at 1. -180, I'm back at 2. Then -270, I'm up at 3. And then I'm back at 2 again. So this graph continues. And I've basically been able to graph 2 of these periods. So let's analyze the equation. Notice that here, the principal axis, this is our D, this is our midline, or our principal axis. If I were to cut this in half right now, I would be able to cut it at that line, y is equal to 2. Notice how it cuts it beautifully in half. The amplitude, the number that's in front of sine right now, is a 1. So from the 2 to 3, I can tell the amplitude is going to equal 1. And then here, the period is going to equal 360 divided by b, which is, of course, 1 as well. The absolute value of 1, which is 360. And sure enough, that's what we notice is happening in the graph. In order for us to create this nice sine shape, then we have 360 degrees. So once again, to refresh your memory, we're going to graph the cosine graph, okay? So at the bottom on the right-hand corner, I've put for you the unit circle so that you remember where these coordinates are coming from. So when theta is equal to 0, cosine, which is going to be the x-coordinate of 0, is going to be 1. 90, the x-coordinate of 90 is going to be 0. The x-coordinate at 180 is -1. Then 0, and then back at 1. So now on my graph, at 0, I'm at 1. At 90, I'm at 0. At 180, I'm at -1. 270, I'm back at 0. 360, I'm at 1. So this is what this part of the graph is going to look like. On the other side, I'm going to do the same thing. I'm going to go to 0, -1, 0, +1. And so this is what my graph is going to look like. Okay, so these are 2 periods of the cosine graph. So we have the cosine, which, like I said, this is what cosine looks like. Negative cosine is going to look in the opposite direction. This is what sine looks like, kind of looks like an S. And in the opposite direction, if I want to graph negative sine, it's just going to go flipped the other way. So this is what negative sine of x is going to look like. So in terms of sine and cosine models, how do I know which one to use when? Well, you're going to use the sine model when you want the initial value of the model to be equal to the location of the principal axis. So you're basically starting halfway between the maximum and the minimum. You're going to use the cosine model when you want the initial value of the model to be a maximum. So if it's a maximum, you're going to let a be greater than 0, or if it's a minimum, you're going to let a be less than 0.